All right, so last time we talked about linear system word problems A, in which we're talking about when two particular situations might be equal or the same. And in those situations, we looked at applying the slope-intercept form, y equals mx plus b, to help us solve for x, and then potentially plug it back in to find our y and show when two situations might be the same or have an equal value. Okay. Now, in this situation, we're looking at linear system word problems B, in which we're trying to find when the amount of each item. Okay. Now, that could be the total number in terms of how many of each item we have. That could be the cost of each item. It just depends on the situation we're looking at. In this first situation, we're talking about James's school is selling tickets to a choral performance. On the first day of ticket sales, the school sold 11 adult tickets, 12 child tickets for a total of $244. The school took in $190 on the second day by selling 14 adult tickets and 6 child tickets. Find the price of an adult ticket and the price of a child ticket. Okay, so what we really have here is two situations. And what you're going to find with these word problems is that we're going to structure our equations in our standard form, ax plus by equals c, where x and y are going to represent the total number or the cost of each item depending on the situation we're looking at. In this situation, x and y are going to represent the price of our adult ticket and the price of our child ticket. Okay, so right away we can already state what this is going to be. If we let x be the price for the adult ticket, and we can let y be the price. Oh, we just put adult. Go back here. Price of the child ticket. Okay, so that's what they're asking us to find right away here is find the price of the adult ticket and find the price of the child ticket. So we can let x and y be our price of the adult and child ticket. Now what we really have here is two situations. We have a day one in which we pulled in a total value, total sum of money. And then we have a day two. Okay, so let's kind of go back and reread the information we have for the first day in terms of ticket sales and day two in terms of ticket sales. So it says on the first day for ticket sales, they sold 11 adult tickets. So we sold 11 adult tickets. And then they sold 12 child tickets for a total of $244. Okay, so they went to this choral performance. 11 adult tickets were sold, 12 child tickets were sold for a total of $244, okay? Then on day two, they took in a total of $190, $190, and 14 adult tickets were sold, and 6 child tickets were sold. Okay, so now I have my two situations. I have my day one and my day two, and I need to use this information in order to write my two equations in our standard form, ax plus by equals c. Okay, where x is the price of the adult tickets and y is the price of the child tickets. Okay, now in terms of being able to set this up to help you guys understand this, put yourself in a situation. Let's say that you and maybe your family are going to go watch a movie. If tickets cost $5 and you and four others with you, so in other words, there's a total of 5 people go, then you'd have $5 for 5 people. How would you find the total cost of going to the movie theaters? Well, it'd be 5 times 5, right? $5 times 5 tickets for the 5 of you, that'd be $25, okay? So when we're talking about this situation here, if I want to start to write my equation, if x represents the price of the adult tickets, for day one here, I would start with 11 adult tickets times how much it costs per adult ticket, right? Well, we don't know how much it costs. All we said was that x represents the price of the adult tickets. So it'd be 11 times x, whatever x happens to be in terms of the price for the adult ticket. Now, go back to the movie situation. So it's $25 for you and your family, you plus 4 others. Well, let's say your little brother or little sister comes along and they have a different price for child tickets. Maybe it's $2. Well, then it'd be that $25 plus $2 for your little brother or sister. Okay, so you have to add on that child ticket. It's the same situation here. We have to add on our child ticket. In this case, we sold 12 child tickets, and we have to multiply that 12 times the cost or the price, however much it costs for a child ticket. So we have 11 adults times the cost for tickets for adults, 12 child tickets times the cost or the price for however many child tickets, and together, when we add the total sums together here, we sold $244 worth, okay, of tickets. So this would be our day one equation, okay? Then day two would follow follow suit. It'd be 14 times X, 14 adults times the cost or the price for adult tickets, plus 6 times the price or the cost of child tickets here, for a total of $190. Okay, so now I have my two equations, two unknowns, my system of equations. Now, when we're in a standard form situation like we are now, you could solve this by substitution, but I think the easiest route would be to go through elimination. So I'm actually going to write this below, and I hope you guys are writing smaller than I am. Okay, I'm going to write this below, and let's see if we can solve this by elimination. Now, remember, with elimination, we have to look for opposite coefficients. Currently, do we have any opposite coefficients here? No. Now, if that's the case, we can look at multiplying some constant to either the top equation or bottom equation so we can create opposite coefficients. Is there some number I can multiply the top or bottom by to create opposite coefficients? Well, actually, if you notice, 12 is double of 6, right? So if I multiplied the bottom by 2, that would give me a 12 over here, right? But we need it to be opposite coefficients. So if the 12 is positive on the top, then we need a negative 2 so that we can get a negative 12 on the bottom. So if I multiply that through, we'd have a negative 28x, and then we'd have a negative 2 times 6, negative 12y to get our opposite coefficient. And then we have 2 times our 190 to get a negative 380. Whoops, 380. So now I can add the top and the bottom together here. We have different signs, so we have 11 minus 28, which is going to give us a negative 17x. Our y's cancel out, and then we have 244 minus our 380, which is going to give us a negative 136. Divide by negative 17 to both sides. Two negatives are going to make a positive, and again, you can use your calculator here to divide it out. But we get that x equals 8. Okay. Now, if you go back to remember what X represents, it's the price of adult tickets. So that means the adult tickets cost $8. Okay. Now, if you go back to what we looked at before, whenever we found X, we plugged X back in to solve for Y, which is what we want because we want to find the price of the child tickets as well. So we're going to pick one of these equations. I'm going to pick the top one since that's the one I didn't cross out here. And we're going to take our X and plug it back in for X. So we'd have 11 times 8, plugging 8 in for X, plus 12Y equals 244. Okay, well, 11 times 8 is 88, plus 12Y equals 244. Two-step equation, we'd have 244 minus 88. We need to subtract 88 from both sides. Okay, so then we'd have, 12Y equals 156. Divide 12 from both sides, and we end up with y is equal to 13. Okay, now again, y represents the price of child tickets, so it's really $13. Okay, so what we would say here, where I got good room, I'm going to write it over here, is that we would say that the cost or the price of an adult ticket is $8, and the price of a child ticket is $13. Whoops, that's not what I wanted to do. There we go. Okay? So the price of an adult ticket is $8, and the price of a child ticket is $13. Okay?